I'm looking for the cosine of 5 pi over 4 radians. In a problem like this, my first move is usually to change radians into degrees. So I'm going to do this conversion by multiplying by 180 over pi. In doing so, I can see that the pi's are going to reduce away. 5 times 180 is 900. 900 divided by 4 is 225 degrees. Another way you could do this is if we have 5 pi over 4, and we know that pi is 180 degrees, we can replace pi with 180 and get 225 that way as well. Either method, I have a 225 degree angle, so I'm going to sketch that in standard position. My initial side is always the positive x-axis, and my terminal side is going to be over here in the third quadrant. I know this is 225 degrees because 225 is 45 degrees past 180. So 45 is going to be my reference angle inside my triangle, which of course I draw to the x-axis. Since this is a 45, 45, 90, each of the legs need to have the same value. I'm going to call it a 1, putting a root 2 on my hypotenuse. Now I do also have to think about negatives and possible sign changes in my triangle. So because I'm in the third quadrant, both x and y are negative. Another way you can think about it is when I go from the origin left 1, left is a negative direction, and down 1 is also a negative direction. When discussing cosine, cosine I know is adjacent over hypotenuse. So from my 45 degree angle here, the adjacent side is this leg that's -1, and the hypotenuse is root 2. So we have a cosine of -1 over root 2. This is a perfectly acceptable answer. You do need to be aware that a lot of times on standardized multiple choice tests, they will rationalize. So if I rationalize this fraction, I need to get rid of the square root in the denominator, which requires me to multiply by root 2. Of course, whatever I do to the denominator, I have to do to the numerator, so that I'm really just multiplying by the number 1. So -1 times root 2 is negative root 2. Root 2 times root 2 is root 4, which is, of course, 2. So these are equivalent values. The green one is rationalized, the red is not.